So continuing here with adding and subtracting polynomials, the question is the difference of two polynomials also a polynomial? The answer again is going to be yes. So we need to subtract these polynomials. Again, if you want, you can rewrite them as the opposites so that you're adding the opposite term. I more likely like to distribute. So again, the first thing I look for is what's the highest power. So that's my x to the 7th. Then I look for the next highest. That's our x to the 4ths. Next would be the x squared, and then the constant terms. So writing in order, highest power, you get the 23 x to the 7th. Next comes the x to the 4ths. So we've got negative 9 x to the 4th minus 9. So really it's plus 9. So negative 9 x to the 4th plus 9 x to the 4th means those are going to cancel out. Next we've got the x squared. It's positive 6, but when we distribute that negative, we'll get negative 6x squared. Constant terms, we've got a 1 minus negative 31, so essentially 1 plus 31 gets us plus 32. And our last one here, I'm going to distribute my negative, ordering things by power. Last one here is the x to the 5th. And we've got the x cubed. Ooh, I missed this x to the 5th. Sorry, that's x to the 5th. Then the x cubed, then the x squared, and then this x is going to be the last term there. So highest to lowest, we've got negative 8 minus negative 2. So that's negative 8 plus 2 gets us a negative 6 x to the 5th. Next terms here is our 7x cubed. That's all alone, so it's going to stay the way it is. And third here, we've got 20x squared minus 9x squared would get us 11x squared, and then that lone 13x gets added in. So again, you have to be very, very careful. Either distribute the negative, make sure you distribute the negative, or you could rewrite it as adding the opposite of that second polynomial. We can do some modeling. So you can look through this example on your own, working through finding the total. So we have to add the polynomials and then doing some substitution. We're going to do a very similar one here together. So according to the data from the Census Bureau, the number of automobiles is modeled by a function where x is the number of years after 1990, and a is the number of automobiles in thousands. The number of privately owned automobiles is modeled by a different function p. We want to estimate the total number of automobiles owned in 2005. So the first thing we need to do is we need to find the total as a function. So our total function should be the commercially owned plus the privately owned. So we'll have to add the two functions together. So again, we look for the highest powers. They've actually already got these for us in standard form, so we should be able to just go ahead and add them. So 1.4 minus 1, we could just say 0.4 x cubed. Got negative 130.6 plus 24.9. It's going to get us negative 105.7 x squared. Looking at our x's then, 1831.3 minus 177.9 plus 1653.4x. And then the constant terms we combine to get plus 129,850.5. So we're dealing with some big numbers here. So that's our total amount of automobiles as a function. So we want to estimate the number owned in 2005. Now notice here it says x is the number of years after 1990. So 2005 minus 1990, means that x should be 15. So if we plug in 15 for x, you can do this on your calculator, but you should get this number in thousands of cars. It's a lot of cars. All right, so summing up a little bit here. How is the degree of a polynomial related to the degrees of the monomials? The highest degree monomial is equal to the degree of the polynomial. So whatever the highest degree is, monomial, that's the total degree of the polynomial. So to do subtraction, you could add the opposite of the second polynomial. How do you model for a whole? If you have functions that model for two parts, you add them. And then what is the result of adding or subtracting polynomials? You're going to get another polynomial.